Hi, this is Work and Energy, Day 4, Example 2. You're on a sled that has got an initial velocity, and it's going to go up a hill, and eventually, due to friction and the fact that you're converting, or you're changing the energy conversion from kinetic energy to potential energy is occurring, you're going to reach a certain height of the hill, and then you're going to stop going up. So, if we do this in terms of energy, I have to find out the frictional force. So in order to do that, I drew a free body diagram, and I know the normal force is mg cosine of 20. My coefficient of friction is 0.2, so I found an average frictional force of 138 newtons. Now, what I have here is I have a situation where at the bottom of the hill I have kinetic energy, and as always I write potential energy, which if I set my reference level to be 0 at that location, that's going to go to 0. And then I am doing work due to friction, and that will equal my final potential energy plus my final kinetic energy. But if we want to know the maximum height, that's where the speed goes to 0. So this will go to 0. Okay. So my initial kinetic energy is 1/2 mVi squared. The work I'm doing due to friction, I found my frictional force to be 138 newtons. Now the angle between the displacement and the friction, again, displacement is going up, friction is downward, that's 180 degrees. And I don't know the distance, but I'm going to call it D. And that is going to equal M times G times H. Well, how are H and D related? If I look at a small triangle here, here's my H, here's my 20-degree angle, this is the distance I go up, this is where I stop. Okay? So I'm not going all the way up the hill. The sine of 20 degrees is H over D. So H is D sine 20. Or D is H over sine 20, depending on what we want to do here. Since we want the height it goes to, let's get rid of D in our equation. Now, the mass, combined mass is 75, and it says I have an initial speed of 5 meters per second. I have to place that in the equation also and square that. Plus 138 cosine of 180 is -1. And then I'm going to place H over the sine of 20. And that equals the mass, which is 75, times acceleration due to gravity, 9.81, times H. Oops, forgot to put the H here. Okay, so now I'm going to do whatever math I can. 1/2 times 75 times 5 squared. That's 937.5. This is going to be a negative number. 138 divided by the sine of 20. That's negative 403.5 times H. And 75 times 9.81 gives me 735.8 times H. Now I'm going to move this over to the other side. So I'm going to combine like terms also. And I get 937.5 equals 1,139 H. And I'm going to divide divide 937.5 by 1,139, and I find that I reach a height of 0.82 meters with sig figs. And that is the end of problem number 2.